Perfect. Okay, it's recording now. So what we're going to do is we've looked at alkanes, a little bit of alkenes, and I'm going to go through that kind of thing again. Right, I'm going to cover alkanes. I'm going to have a look at the combustion, and I'm going to have a look at cracking and some of their reactions and alcohols. After I've done that, you've got to finish, I don't know, maybe 20 minutes of work there. Here are some exam questions based on alkanes, crude oil, fractional distillation, and cracking. All right, so general formula of alkanes, just to remind you guys, is CnH2n plus 2. I've already shown you how to use that to work the number of carbons out. Okay, now we're going to have a look at combustion, both complete and incomplete. What's really nice in this example is they've given you the products of carbon dioxide and water. And some of you guys got this pretty much okay, except for one thing. You've got to have oxygen on this side. All right, you're burning it, so you must have oxygen. And that's all you need to add. All right. So after you've added it, you now need to balance it. Always, when it comes to organic chemistry, start with your carbons. I've got one carbon. I've got one carbon. I'm happy. Next, start with your hydrogens. I've got 4. I've got 2. I'm going to put a big 2 there. Okay. Now, last part. Work out how many oxygens you have on the right-hand side. I've got 2 oxygens here, and 2 times 1, 2 oxygens there, so 4 in total. 4 is the total number of oxygens. This is complete combustion. If I've got 4 oxygens on this side, I need 4 oxygens on that side. I put a big 2 there, because 2 times 2 is 4. I'm going through this quite quickly, because a lot of you managed to get most of this right. All right. Incomplete combustion means you're either going to make CO, carbon monoxide, or carbon. So again, whenever you're burning, you're going to produce oxygen. Of the 2 atoms in hydrocarbons, the most reactive is hydrogen. So hydrogen, no matter what you do, you are going to form water. Now I've chosen carbon. You can choose either. I've chosen carbon. And that's it. I've got all my elements and compounds in there. Now balance it. 1 carbon here, 1 carbon there. I'm a happy man. 4 hydrogens there, 2 hydrogens there. I'm going to have to put 2 here. Perfect. Now let's balance the oxygens. 2 oxygens here, none there. 2 oxygens there. And I'm done. That's it. Finished. Okay. Now, an example of cracking. All right. Now, if I have 1, 2, 3, 4, and you never get them this small, but I'm going to use a small one. This is butane. 1, and it's got, when we look at butane, and we'll not waste time and draw hydrogens around it, I'm going to heat it up and crack it. And I'm going to assume I'm going to make a smaller one, and this is going to be methane. And this one, I am going to draw the hydrogen so you can see where I'm thinking. Cracking is about making smaller molecules from bigger molecules. Now, this is butane. It's an alkane. So I've got 4 carbons there. I've got 1 carbon there. So my other molecule must have 3 carbons. You cannot lose any carbons. So if I've got 4 on my left-hand side, I've got 4 on my right-hand side. There's nothing else. There's no plus oxygen. You're not burning it. You're just breaking them. Now, hydrogens. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. On this side, I've got 4, meaning this molecule must have 6. 1, 2, 3, 4, oh dear, 5, 6. This has to be an alkene. Otherwise, you've got too many hydrogens. So whenever you crack a hydrocarbon, you'll get an alkane and an alkene. But however many carbons you've got on your left, you must have on your right. However many hydrogens you've got on your left, you must have on your right. General formula for alkenes, CnH2n. Went through that last time. All right. Okay. So, that's all those covered. You've got a few questions here you can do or should do. You've also got this idea of what are alkenes. Alkenes are a homologous series of hydrocarbons. I've already told you the general formula, CnH2n. Ethene, my elephant prefers bananas. So pentene is 5. So if I'm going to draw pentene, 1, 2, 3, 4, 5. It can have only needs one double bond for an alkene. The alkenes mean it's got a double bond. Make sure every carbon only has 4 dashes, 4 bonds, and that's it. I am done with pentene. All right. The really interesting thing about the reaction of alkenes is that if you look at them here, the way that I would explain this to myself, and I'm thinking about it, and I've got images in my head, this is ethene, okay? And this is bromine. To me, what's happening is I am breaking this bond and breaking that bond. And the bonds go here, and my bromines pop there. So I hope you can see how I've broken this bond here, got rid of it, and placed each bromine atom on either carbon atom. All right. This is the production of alcohols. The way I look at this is one way of looking at water. I'm going to break that. A hydrogen is going to go here, and the OH is going to go there, and we are going to get rid of that double bond. Okay, so what we're going to end up with is that double bond disappearing, the water snapping. One of these hydrogens is going to end up here, and the OH, that one, is going to end up there. Now, if it has an OH on it, it is an alcohol. So again, I'm going to draw you the last one here. Bute. My elephant prefers bananas. 1, 2, 3, 4. Put an OH anywhere you want. It really doesn't matter. Rest of them are hydrogens. Okay. Uses of alcohol. Alcoholic drinks. Cleaning. You can even use it as a fuel. Now, I've not really written that down, and I'm not going to, because part of this is you doing a little bit of research. What are the uses of alcohols? Find them out. Okay. After you finish those, we've got these exam questions here. Yay, 8 minutes. Why?